So one of the wonderful things about getting ready to code is sometimes we find projects like we had that present us with a new opportunity to list our blocks. So the fun thing about this new program that we're calling list blocks is that we're going to be able to chart, for example, the ability to input a PWD. I'm using standard flowchart symbols, and if you don't know much about flowcharting, once again, take a look at my flowchart educational opportunity up on Udemy, as well as other educational content providers. And once we input the PWD, whether we get it from the command line or an environment variable, or in this case, we simply hard-code it into main, first thing we're going to do is list all of our Python files, and once again, hard-coded, so we don't have to input that, or use a data symbol, so that we can perform the sort file name procedure that we understand how that works. Just going to use sorted or the list.sort, whatever we choose to do, then find our gatekeepers. Once again, adequately discussed. We don't need to talk about that anymore. And then finally, we have the show kept name plus number. In other words, what we found in the keepers before we end our program. Now, we also discussed, of course, that we could have an error. And if we have an error, we're going to show that error to the screen. But interestingly, if you look at the code, you discover that in addition to displaying the error, if we have some data that has been accumulated before the error, of course, we're going to show those kept names and numbers as well. Very important distinction. And if they don't want us to do that, or just show the error, our user could obviously say, nope, we want to go right to done, for example, after display error, rather than hide that error on the standard output of the standard error. Anyways, it can make some very interesting discussions, and those discussions are why we like to chart activities so as to build consensus and get clarification not only on normal flows, error flows, but perhaps error recovery and alternate flows to our list blocks pie situation. For example, logging errors to the cloud or the console or the system log utility as well. So diagramming isn't really necessarily evil, and then more importantly, as we look at our code, we'll see that this is indeed a high-level requirement. It's not necessarily telling us how we're going to write our code, simply what we need to do in order to test properly, as well as to make sure that everybody agrees that the way things work is the way things are supposed to work before we write a single line of code. Well, welcome back to Hackatrack, or Hackatrack, I suppose we could say. And our mission, and since you're here, you probably decided to accept it, or here, was to take our second mission where we did our list blocks kind of situation where we had many gatekeepers and our list files to make it into something that would basically renumber everything that we're doing so that our sort didn't have to happen anywhere besides perhaps on the files. And why would we want to sort the files? Well, because when we sort the files, of course, we're going to make sure that all of our numbers are the same for each module, unless we add a new module, in which case all the numbers would change. And once the numbers change, of course, it's really easy to detect any changes in our numbers in what I'm going to be calling a block manifest. So certainly, from a certain point of view, sorting our file names could matter a great deal, and other times not. For example, if we move Starbase to a different file or put all of our ships in one file, sorting everything by the name of the class would be another view that we'd want to have as well. So we're not looking for a quest of the perfect view, but rather what we're doing is discovering many types of handy views that we'd like to keep around for doing our spelunking. So without further ado, let's look at another view. So our list structure function, taken from the name we used to first described it, became very, very important because our view is becoming file-centric, and our gatekeepers, of course, remain the same. As we list our structure, of course, our results are going to be everything in the order things were encountered in our file, assuming we didn't have an exception. So while we're not using list blocks anymore, the one thing we are using, of course, is having everything on a line. And while 99.59s of whatever we see in Python will have a definition on a single line, certainly when we're talking about having our gatekeepers, you have to ask yourself what would happen if things were not on the line. Well, do we really need to worry about such things? Well, I think we do, and let's take a look at that problem, because what we call that in the industry is an edge condition. In other words, everything works fine as long as you keep in the middle row, but if you go up on the shoulder, that's kind of edgy, things get kind of messed up. And if we really want to make sure all of our tests run,
edge. Bummer.
What we'll need to do is take a look at the 80-20 rule. So our mission was completed, and our requirements to have a major class numbering and our minor class definitions, as well as to show our module name, provides us with some additional insights that we might not have considered. For example, here we see in test map sparse that we have no classes, but we have a 0 and a 1 function definition, which, to tell you the truth, is a little irksome. It'd be nice if we did something else. We could put that on the to-do list. It's not going to cause any big deal, because right now our major requirements have been fulfilled. And more importantly, we can see, for example, or another edgy case was where, for example, we had files like the glyphs file that had no classes or function definitions in them at all. So we obviously have a bit of a truth table to go through here. We have classes and functions, what we were looking for, in a file. We have a file with neither classes nor functions in there. And while we might have something with just classes in there, I can't really imagine that being more than a distant edge condition. But here we have a file that simply has functions, and we'll fix that later on if we decide to. And this triage is very much what we're trying to understand as we go through our ready stage, doing our 80-20 bits and saving our comments and observations into our storyboards or into our documentation, so as to probably follow what most people do as an agile process. Once again, nothing wrong with it, and simply because we choose to call it a story doesn't mean it's any different than what we were doing in our exploratory phases for waterfalls for decades. Find a need, we fill a need. And the important thing is, in the agile world, we triage and order our requirements by a rational implementation approach, giving people time to test while we're doing something else or working on another subsystem, and even more importantly, to manage our change and officially lock our revisions down with test cases, which is why I think Agile is so important. And that thinking before we code is why we have a ready and a set mode. Yeah, I love the rhyme. It's a disease. Maybe you'll catch it too. So this geek's quest to solve the 80-20 rule led me over to artificial intelligence. As we see here, one of those AI-generated wonders is when I asked it to find Python files and then extract information from those files. You notice that their list files capability, once again, had a PWD they call a directory, and they used a wonderful list comprehension. I think the AI was just showing off, to tell you the truth, so as to return a list. And lo comprendo, when you list dir, we're going to get whatever comes out of that as F. And if F ends with Python, we're going to join it with our directory to give us a fully qualified name in our list. Easy when you know how. Once again, Python Beyond the Basics is your way to discover that from my training inventory as well. So the fun thing about their extracting things from file is they use a new module, which, to tell you the truth, I haven't even bothered using at all, called the AST module. The AST module is the way, let me go ahead and have them explain it, because they'll do it better than me. Here again, brought to us by the virtue of AI, we have the idea of using an abstract system trees, ASTs, love it, which have wonderful functions for parsing, believe it or not, Python. Oh, look, we've got a walk, we've got a unparse, pushing things and popping things off the stack, the ability of transforming our nodes. We can do a lot here with the AST module, and it's by importing the AST module, of course, which we can find in ast.py if you're really interested, we can look at how we could walk through the grammar or the abstract grammar, which would include, of course, class definitions, function definitions, and all those wonderful things we're trying to find here in our definition of what we could do with the module. If you're really interested, go ahead and take a look at the AST module, but more interestingly, look at how we're using the gulp mode for our file. We're also using Unicode, which is not a bad idea. It's a default, but if it isn't, you might as well specify it. So you can throw an exception if it's not. And more importantly, we're going to go into what I call gulp mode. We're going to eat the whole file and put it into a string so that we can save the name for regurgitating as we do our walk through our tree to see if our node is an instance of the class definition. We can obviously use function definition, everything else you want it to do. And if that's detected, we're going to append that to our results. They call it class names. 2 points for the AI to return their results. And so once we copy and paste in our literal, we see that we had a little problem that needed to be fixed because we didn't get a fully qualified name when we opened things up. We had to actually fully qualify our name so as to extract our classes. Wonderful. Works fine. Now you notice we also have a problem with a Unicode format having a non-printable character in there, to be expected, but we know that there's not really much going on in Trek strings. So we could fix that later. Once again, 80-20, maybe 99.0009, round it up. But we did see our familiar list of items, and it's not really wonderful, but it did work. But more importantly, it shows us the wonderful things we can do by using the AST module and checking for things like class definitions of other things, which could be, once again, very handy if we're doing our own artificial intelligence. So leaving this source to be with you, certainly something that you can run and enjoy on your own. So you also notice here that we're using a fully qualified name with a slash at the end to allow us to make our fully qualified function work. And the reason why we really couldn't use a literal here, if we wanted to do that, and I've always found this massively annoying about Python's literal mode in general, is that if we choose to use a literal string, as we see here,
does not compute.
We get a problem because even though we are in literal mode, we can't escape an end quote. Incredibly annoying. Wish they'd fix it. Been with us for so long, I could give you a rant, but I ain't going to do it. Oh, your mission, if you decide to accept it, is to revisit and refactor what we've just created so as to properly number and list our classes by file name, as well as class definition and member functions, so as to see if you can use my code, if you like, so as to create something that makes a little more sense. It maybe works a little better. You can go ahead and tackle our edge conditions if you would, or even use AI, which I will be doing, so as to see if you can make our solution faster, cheaper, or better to run. And by better, of course, I mean refactoring so our modules make more sense, or perhaps to simply reuse AI in a different way so as to make it make sense later on.